Dear listeners, it's a discussion on electric field and electric flux. Any charge Q develops an electric field around it. If we keep a charge Q dash at a point P at a distance r from the charge Q at O, then the magnitude of electric force on Q dash is F equal to CQ dash divided by R square according to Coulomb's law. This force acts along OP as shown in the figure. The force on an unit charge at P is E equal to F by Q dash, that is CQ divided by R square. It is called electric field strength at the point P, or electric field intensity, or simply electric field at P. It is also directed along OP. The imaginary lines along which electric forces or electric fields act are called electric lines of forces. The electric lines of forces for a point charge Q is shown in figure 2. These are the straight lines diverging from the charge Q. The electric field E is stronger where the electric lines of forces are dense. E is directly related to the surface density of electric lines of forces. The surface density of electric lines of forces is the number of electric lines of forces emerging normally from an unit surface area. It is called electric flux density. The total electric lines of forces emerging normally from a surface is called electric flux phi E of the surface. E be the electric field at a point P. It means that E lines of forces are emerging from an unit plane surface kept perpendicularly with E. So the total electric lines of forces coming out from a perpendicular plane surface of area S is phi E equal to ES. That is, the electric flux phi E of the surface is phi E equal to ES. If the surface makes an angle theta with the electric field E, then the component of E along the normal to the surface is E cos theta. Then we must say that E cos theta lines of forces are coming out normally from an unit area of the surface. Then the electric flux of the surface is phi E equal to E cos theta into S. that is Es cos theta E dot S. S is a vector. Its direction is along the normal to the surface. This calculation of electric flux phi E is applicable for a plane surface in an uniform electric field. If the surface is not plane, if the electric field is not uniform, then the surface is divided into a large number of small surfaces. These small surfaces are called differential surfaces. These surfaces are plane. The electric flux of such a differential surface is d phi E equal to E dot ds, and the total electric flux of the surface is phi E equal to integration E dot ds. It is an open surface integral of the electric field E, that is integration E dot ds is an open surface integral, as our surface is open, it does not enclose any volume. For a closed surface, the total flux phi E equal to closed surface integral E dot ds. Finally, the realization and the definition of electric flux is that the electric flux is the surface integral of the electric field E over the surface. Thank you.